This completes the lesson that we learned last Friday, just on all the angles that are formed with parallel lines in a transversal. These are where we introduce the algebra into the solving skills for these. So we're going to look back just basically at the types of angles we looked at. And we started with just what parallel lines are, that they never intersect. We had the transversal, and the transversal is the line that cuts these two parallel lines up, and it creates 8 different angles. And these angles are related, and they have certain names. We said interior angles are angles that are inside the parallel lines. And so we had this situation here where y and x are interior angles, but we'd say y and y are interior alternate angles. And what we said is x plus y has to equal 180 degrees. And if the lines are interior alternate angles, like y on that diagram and x is on that diagram, that they'd be equal in measure. Then we look down at exterior angles. So they're outside the parallel lines. And the same sort of situation holds true that the angle B and the angle A that are on the same side of the transversal, those will just be called exterior angles. And if one's on one side of the transversal and one's on the other, like these two B's, these would be exterior alternate angles. And exterior alternate angles would also have to be equal. Then we talked about corresponding angles. Corresponding angles, they're on the same side of the transversal, and they're equal in measure. So C and C, D and D, F and F. And vertically opposite angles, those are those angles that are just in one section here, like in one of these little crosshairs, they're across from one another. So R and R would be vertically opposite, and I could say V and V if I wanted to. Those are also vertically opposite, and vertically opposite angles are equal in measure as well. So that brings us up to the more challenging questions. The last day we looked at how these things, we could prove that they're parallel. We had to know how to name the angles. And then this is where we left off with the backside of that handout. So right now it's going to say in each diagram, solve for x, use the value of x to determine the measurement of the indicated angles. So first off, you have to identify what type of angles these actually are representing. So when we look at the first diagram, here's the transversal. The parallel lines are there. We have this angle and this angle. They're outside the parallel lines, so these are exterior angles. And they're on opposite sides of the transversal, so these are exterior alternates. And then we did say with parallel lines, there is that sort of cheating sort of method where if this is an obtuse angle and this is an obtuse angle, we know that if there's a transversal going through, those two angles have to be the same. So we could write this as the angle 3x plus 55, that top one, has to equal 5x plus 25. So here's the situation that will help us solve for x. Now we just have to use our algebra skills from grade 9 and 10 to actually solve for the unknown values. So we want to bring all of our variables, in this case x, to one side of the equation and all of our numbers to the other side. First thing we're going to look at is where are there more x's? Well, there's more x's here on the right-hand side. So if there's more x's on that right-hand side, we might as well bring the x's over there. So this is a positive 3x out front, so to get rid of it, we subtract it from both sides. So 3x minus 3x on the left, there's nothing left. We're just left with a positive 25 equals 5x minus 3x is 2x, then plus 25. So now we only have one variable to deal with. We're going to move all of our numbers now to the left-hand side. So I'm going to subtract the 25 first. And that gets 2x equals 30. And then if we just divide that 2 out, we have x is actually equal to 15. Now that doesn't mean that the angle itself is 15 degrees. The angle itself is a function of x. So if we look up here, we actually have 5x plus 25. So that's like 5 times 15 plus 25. And if you do that, 5 times 15 is 75 plus 25. This is 100 degrees. And likewise, this up here, since they're equal, would also be 100 degrees. So the question's asking solve for x and find those angles. Well, the angles are 100, and the x isn't 15 degrees, it's just 15, some value of 15. So the second example here, a little bit different. Our parallel lines are going up. The arrows on those lines indicate that they're parallel. And if we look again, we got to identify first the transversal. And then we look at the angles. There's an angle that's 8x right here, and an angle that's 10x right there. Now those two angles then are inside the parallel lines. So if they're inside the parallel lines, those are interior angles. Now they're both on the same side of the parallel lines, so they're not, or sorry, on the same side of the transversal, so they're not interior alternate angles, they're just considered interior angles. So interior angles in there would add up to 180 degrees. These two angles are what we call, and it's back in our notes, supplementary. So the angle 10x, when added to the angle 8x, because they're both inside the parallel lines and on the same side of the transversal, it has to equal 180 degrees. So now we do some simplification. 10x plus 8x, 18x is 180. And then divide out the 18. X equals 10. So that's the first thing the question asks you. What is x? And then it says go and find those angles. Well, if x equals 10, this is 8 times 10. That's an 80-degree angle. And here, this would be 10 times 10, so that is a 100-degree angle. So we solved for x first, using our information about what types of angles we're dealing with and how they're related. They're either the same or they're supplementary. They add up to 180. Solved for x and then put it back in the equation to figure out what we're actually looking for.